everyone. My name is Sangita Purkait, Assistant Professor of Swami Vivekananda Institute of Science and Technology. Today we are going to discuss a problem which is the chapter of discrete joint distribution. In this chapter, the question is two discrete random variables capital X and capital Y are connected by the relation 2x plus 3y plus 4 equal to 0. Then prove that the correlation coefficient between capital X and Y is -1. Now, what is correlation coefficient? This correlation coefficient is denoted by rho of xy, and the formula of correlation coefficient is covariance of x comma y. This COV of x comma y means covariance of x comma y divided by sigma x into sigma y. What is sigma? Sigma x is the standard deviation of capital X and sigma y is standard deviation of capital Y. Now, our question is we have to prove that this correlation coefficient rho xy is equal to -1. So, correlation coefficient is always depending on covariance and standard deviation. If covariance is 0, then correlation coefficient is also 0. So for finding correlation coefficient, we have to find first the covariance. Now, there is a relation which is between x and y, that is 2x plus 3y plus 4 is equal to 0. Actually, we have to use this relation for finding this covariance or standard deviation. Now, let us take expectation both sides. Expectation means capital E, 2 capital X plus 3 capital Y plus 4 equal to expectation of 0. E means expectation. Okay, so E of 0 is 0. Now, expectation of 2x plus expectation of 3y plus expectation of 4 is equal to 0. Now, there is a formula of expectation that expectation of any constant into x will be constant into expectation of x. Expectation of ax equal to a into expectation of x. So from this, expectation of 2x can be written as expectation of 2 into expectation of x plus 3 into expectation of y plus expectation of any constant will be that constant. So that will be 4. Now we know what is expectation of x. Expectation of x is the mean. Expectation of x means mean, and mean can be denoted by x bar. So that this can be written as 2x bar plus 3y bar plus 4 equal to 0. Okay. So this is our main equation. This is equation number 1, and from here we get 2x bar plus 3y bar plus 4 equal to 0. This is equation number 2. Now we will use these two equations for finding covariance. First we will find covariance, then sigma x and sigma y. Now, what is the formula of covariance? Formula of covariance is expectation of x minus x bar into y minus y bar. We know x bar is mean, y bar is also mean. Now, expectation of x minus x bar as it is, but from this relation we will put the value of y, and from this relation we will put the value of y bar. Okay, from this relation we will if we calculate y, we get 3y equal to -4 minus 2x. So y is equal to -4 minus 2x divided by 3. So in place of y we will put -4. I will write -4 by 3 minus 2x by 3. Similarly, if we get, since this and this equation and this equation are similar, just x a plus x bar and y a plus a y bar. So from here also y bar will be -4 by 3. So minus plus 4 by 3 minus plus 2x bar by 3. Since it is y bar. Okay. So plus minus 4 by 3 cancel. So expectation of x minus x bar into, from here we can take -2 by 3 as a common part. Okay, we are taking -2 by 3 as a common part. -2 by 3 common. Okay, so -2 by 3 common mile, then x minus x bar. X minus x bar. So -2 by 3 will be outside the expectation. Expectation of x minus x bar into x minus x bar. So that will be x minus x bar and whole square. Now this is the formula of variance of x. Variance of x has a formula which is equal to expectation of x minus x bar and whole square. So this can be written as -2 by 3 into var of x. Okay. Now there is a relation between variance and standard deviation. Standard deviation is equal to positive root of variance of x. That is, if we square both sides, standard deviation is square equal to var of x. So we can write, and var of x, let standard deviation of x can be written as sigma x. So sigma x is square equal to var of x. Okay, so in place of var of x we can write sigma x square. Now this is the value of covariance of x comma y. Now in this relation, this value we can get, this value is -2 by 3 sigma x square. Now we will find sigma x and sigma y, relation between sigma x and sigma y. From this, for finding sigma x and sigma y, we will from variance of x. Okay, now variance of x equal to, we know this is the formula of variance of x, expectation of x minus x bar and whole square. Now put the value of x. What is x? 2x plus 3y. What was the relation? 2x plus 3y plus 4 equal to 0. 2x plus 3y plus 4 equal to 0. So x is equal to -4 minus 3y divided by 2. So is it equal to expectation of, in place of x we will put -4 by 2, that means -2 minus 3y by 2, and minus x bar means minus plus 2 plus 3y bar by 2 whole square. Okay. So plus minus 2 cancel. Expectation of, if we take -3 by 2 as a common part, y minus y bar total whole square. So that will be, if we square this, we get expectation of 9 by 4 into y minus y bar whole square. So that is equal to 9 by 4 into expectation of y minus y bar whole square. Now if this is equal to variance of x, this is equal to variance of x, so that will be also variance of y. So that is 9 by 4 into var of y. Now var of x equal to, we get var of x equal to 9 by 4 into var of y. Var of x can be written as sigma x square equal to 9 by 4 sigma y square. Now if we cancel square both sides, we get sigma x equal to 3 by 2 into sigma 1. This is another relation. So this is the value of relation sigma x sigma y. This is the value of covariance. Now we will put in the correlation coefficient formula. Rho xy equal to covariance of x comma y divided by sigma x and sigma y. Covariance is -2 by 3. Yes, minus 2 by 3 sigma x square divided by sigma y as it is, and in place of sigma x we will put 3 by 2. No, since this is sigma square y, so we will put in terms of sigma x. Okay, sigma x into value of sigma y. From here value of sigma y is 2 by 3 of sigma x. So value of sigma y is 2 by 3 of sigma x. Sigma x square cancel, 2 by 3 cancel. This is equal to -1. This completes the proof. So So in this way we can calculate from covariance to correlation coefficient. Thank you so much.